Okay, so back on for the second half of the November 2020 paper 1. This is worth 3 marks. Now, it's really important as the second half of the paper goes on that you don't just think, oh, the first half of the paper is for me if I just want to get half marks and get up towards that grade 7. No. You're going to have to be picking up marks from every single question as you go. Right, so we've got 3 different things that can happen. We've also got the lose, haven't we? And losing is going to happen 0.3 plus 0.1 is 0.4, 0.6, because it's all got to add up to 1. Now I would draw a tree diagram first of all to see what's going to happen. So she could win, she could draw, and she could lose. She's going to play 2 games, so she could win, she could draw, and she could lose. She can win, draw, or lose, win, draw, or lose. Now, if we pop in all of these, you'll get a mark just for setting this up. So winning is 0.3, drawing is 0.1, losing is 0.6. Just do that again on all of these. Because they're independent events, it's not saying anything is happening on the second game which would be any different. It's exact. Right, so now she wants exactly one of the 2 games. This is winning and winning, so that's not exactly one of them. Winning and then drawing, that's exactly 1. So I want that one. And I'm going to work it out by multiplying along the branches. 0.3 times 0.1. Winning and then losing, that is also exactly 1. Drawing and then winning, that is exactly 1. 0.1 times 0.3. Drawing and drawing, no wins. Drawing and losing, no wins. Losing and winning, yeah, that's 1, isn't it? 0.6 times 0.3. And then losing and drawing and losing, they're not winning 1. So, and means multiply, so this is winning and drawing and winning. And then once we've got that, any of these 4 could do it, and or means we add them together because that's going to make it more likely. 0.3 times 0.1 is 0.03. 3 6s are 18, so 0.18, 0.03, and another 0.18. Now all we have to do is add up these 4. 3 and 8 is 11, plus another 11 makes 22. 1, 2 plus the 2 makes 4, so it's 0.42 is the final answer. Okay, this is what's known as a y equals mx plus c question. So m is the gradient and c is your y-intercept, what you get when x is 0. So the gradient is 3 for line 1. A perpendicular gradient, to get a perpendicular you need what I call the negative reciprocal. So the opposite of going up 3 for every 1 you're going is going to look like that. It's going to be a very shallow one on a negative gradient. So the gradient is going to be 3. Think of as 3 over 1. The reciprocal of 3 is a third, but it's going to be negative. It's going to be negative a third. This means that our equation, and you'll have 1 mark for saying this, is going to be y equals minus a third x plus c. And all we need to do to get the final 2 marks is work out what that is. Now, I know 1 point for line 2. On that point, x equals 9 and y equals 5. So I'm going to substitute those into this equation to find out what c should be. 5 equals minus a third times 9 plus c. A third of 9 is 3, so times it by would be negative 3. Then if I add 3 to both sides, I get that 8 equals c. Therefore, my final answer is going to be y equals minus a third x plus 8. Question 16. So two parts. The second part's very short, but always one you should have a guess at, even if it's gone wrong on the bit above here. So this is a catching and replacement thing. She's catching bees. Don't ask me how you do that, and don't ask me how you put a mark on a bee. But anyway, she's put marks on B and she's returned them. She finds out the second day we've found that 20 of them have been marked. So they've caught 20 out of the 90 that were there. So if I were to make that into that would be 2/9, wouldn't it? Another way of thinking about it is, I had 20 before. What do I times it by to get 90? Well, 90 divided by 20 is 4.5, isn't it? So if these are proportional, these bees that have been marked to the total number of bees that are around, then there must be 4.5 times as many of all of those bees. So I'm going to do 120 times 4.5. So 5, 10, 5, 4 times 0, 4 times 2 is 8, and 1. So that would give me, oh, 10 plus the 1 there gets us 6, doesn't it? 14. That doesn't quite, oh, sorry, 4 times 1 is 4, isn't it? Plus the 1 makes 5. So 5, I've got a decimal point in there, put a decimal point in there, it'd be 540 bees. 4.5 times 120. Nicer ways I could have done that. Right. Have a look at that. Shirley assumes none of the marks had rubbed off between Monday and Tuesday. If she's wrong, what effect would that have? Well, that would mean that there would be some that that had been marked, that would be a higher proportion were actually marked than she thought, so that there would be less bees altogether. There will be fewer bees. Anything along those lines. You do not have to write a lot. Right, rearranging to make the subject of the formula. 4 marks for this. It's going to need a bit of factorising as a bit of a clue. So first thing to do is get rid of the bottom of the fraction by multiplying by f minus 4. So you could do that by writing it as a bracket, or you could just say I'm going to write times d by f and by negative 4, which will give us df minus 4d equaling, and I'm going to expand this bracket as well at the same time. 3 times 1 is 3, 3 times f is 3f, so it's take 3f. Next we need to get all the terms involving f onto one side, so I'm going to add 3f to both sides, so that gives me df plus 3f take 4d is equal to 3, and I'm going to move the term not involving f to the other side, so I'm going to add 4d to reverse minus 4d, gives me df plus 3f equals 4d add 3, doesn't matter if you write it the other way round. Now I'm going to factorise this, because at the moment I've got 2f's. I don't want one f, I just want to have an f on its 2f's, I want an f on its own. So if I factorise, that's going to give me f with d plus 3 in the bracket equals 4d plus 3. And now's the clever bit. This is being times by d plus 3. We just need to divide by d plus 3. And that's going to give us f equals 4d plus 3 all over d add 3. Now, proportion is always a bit tricky. Proportion to a square root, people get confused about. Chucking in this percentage is actually putting in a bit of index law into it, makes it a really nasty question. There's only 3 marks for it, so it's one that you don't want to get too hung up on the exam, but give it a go. So I would always start by saying, right, if it says x is proportional to, use a proportional symbol to y, and you're probably going to get a mark if you can just say that that means I could write a formula saying x is going to be k multiplied by root y. Now, if you increase something by 44%, you do that by multiplying by adding 44% to 100% gives you 144% is 1.44. So I could say that my x is going to be whatever k is, we don't know that, it's going to be multiplied by the square root of y times 1.44. Now I'm just going to start thinking about that bit there. So the root y times 1.44 is the same thing as saying the root of y multiplied by the root of 1.44. So if I think about it, x is going to get bigger by whatever the square root of 1.44 is. So that's what we need to think about. So the square root of 1.44. Now we haven't got a calculator. What the flip are we going to do? Well, let's think about putting it into a fraction. Fractions are our friends. So that's going to be 144 divided by 100, isn't it? When we're talking about percentages. So now we can say that that is going to be the same thing as, what could we do with this? We could simplify it, couldn't we? So if I just, let's just keep it simple, just do it one bit at a time, halve them both, gets us to 72. Doesn't help me yet, but I could still halve them again, couldn't I? 36 over 25. Now, index law again says we could do that, and I've done that because I've spotted that these two are both square numbers. The square root of 36 is 6, the square root of 25 is 5. So we're actually going to be multiplying it by 6 fifths, and 6 fifths is 1.2, and 1.2 is a 20% increase. If you multiply by 1.2, it's a 20% increase. So 20% increase gets you your 3 marks. If the last one didn't go great, don't worry about it. Reset, have a go. What can you do here? Now all a function is a bit like saying y equals something. It's another way of looking at this thing. So that our input is x. So x is 5. So all we've got to do to find g when it's 5 is put 5 in instead of x. 2x means 2 times 5. 2 times 5 is 10. So we're going to have 10 plus 1. 3 times 10 plus 1 is 11, so that gets us 33. The second part, GF is 9. So when this happens, you do the function closest to the bracket first. So I'm going to send 9 through function x. 12 over the square root of 9. The square root of 9 is 3, so it's 12 divided by 3, which is 4. I now put 4 into the g function. The g function is just the same as we did before. Replace the x with 4, gives us 2 times 4 plus 1, so that's going to be 2 times 4 is 8 plus 1 is 9, so it'll be 3 times 9, which gets us 27. Right, now we've got one more coming on here. G to the minus 1. That means the inverse function. We know that and we want to know what the value of it is when x is 6. We know that g function is 3 brackets 2x plus 1. First thing to do is to find out what that would be. And what we do is, if you replace function g with y, we're going to rearrange to make x a subject of the formula, because we're going to reverse the process. It means reversing the process. So if I divide both sides by 3, I get y over 3 equals 2x plus 1. Then if I take 1 from both sides, and I'm just not trying to be too clever and do too much at once, just think about it as we go. Y over 3, take 1. Then what would I do? I would divide by 2. So this is going to look a little bit weird, but you can actually have a fraction inside a fraction. I'll put a big fraction line underneath it all. Is going to equal x. Now at this point we can say that the inverse function is equal to, and at this point I just replace that y with the x so that I can go the other way. X over 3, take 1, all over 2. And now I'm just going to put the value of 6 in there. So 6 divided by 3, take 1, divided by 2. 6 divided by 3 is 2. 2 take 1 is 1. 1 divided by 2, well, that is a half. And a half is my final answer. And you may think it's a lot of work for 2 marks, but just keep practicing it. The more you do it, the cleverer you'll feel. And picking up any marks you can at this stage is all great. Even if you're trying to get a grade 9, you can lose out on quite a lot of marks, but that doesn't mean you just want to leave stuff blank. It means you want to have a go at it as much as you can and see what you get at the end. You will get somewhere by guessing, because you know it all in there somewhere. Right, here's a 4 marker that a lot of people will leave blank. It's all about thinking about the difference between 2 squares. You know how x squared minus 25 it factorizes to x plus 5, x take 5, and the reason for that is when you multiply that out you get minus 5x and plus 5x and they cancel each other out. It's basically that idea. But before we do anything, let's sort out, this is all about root 5 in the answer. So I'm going to think about root 180. Root 180 could be written as root 5 times however many 5s go into 180. 5 goes into 18 3 times with 3 left over. 36. So, and the square root of 36 I know is 6, so I can say that that is 6 root 5. So the first thing I'm going to do is then rewrite it as 6 root 5, and I'll get a mark for doing that, minus 2 root 5 over 5 root 5 take 5. Now this is just, it's a bit like algebra, this stuff of surds. We don't really know what the square root of 5 is. It's a horrible number, but we know if we times it by itself we get 5. So just think of it as x. 6x take 2x would be 4x, wouldn't it? So we've got 4 root 5 over 5 root 5 take 5. Now, if you look at what it's saying up here, we've just got a square root at the top, which means this is all to do with rationalising the denominator, even though it hasn't said it. And we do that using this little trick here, and saying, remember, if that was like x minus 5, I would do x plus 5, because that would help me cancel out the roots. You'll see what I mean as we go along. So I'm just going to have exactly the same thing written here, except it's going to be a positive instead of a negative. And if that had said plus 5, I would have put minus 5. And I'm going to multiply top and bottom by that, because that won't change what it means, but it'll help us to simplify things out. So I'm going to use a couple of grids to help me do this. So I've got 4 root 5 that I'm going to multiply by 5 root 5 and 5. And I've also got 5 root 5 take 5. And I'm going to times that by 5 root 5 and plus 5 as well. So 4 times 5 is 20. Root 5 times root 5 is 5. 4 times 5 is 20, so that'll be 20 root 5. So that's giving me 20 times 5 is 100 plus 20 root 5. Over here, 5 5s are 25. Root 5 times root 5 is 5. So that'll be 25 times 5. And here we're going to have 5 5s are 25 root 5. Here, negative 25 root 5. And negative 5 times 5 is negative 25. We're going to add those two together and they're going to cancel out. And that's going to give me 125, take 25, which is 100. Now, I can put those into here. So the top, the numerators was this one here, wasn't it? 100 plus 20 root 5 all over 100. That's not quite looking like that yet. So let's write that out again over here where I've got a bit more space. And remember when you first learnt to add fractions, you added the numerators if the denominator was the same. I'm just going to reverse that process a little bit and split it into two fractions. 100 over 100, add 20 root 5 over 100. And then look to see what I can do in terms of simplifying. 100 divided by 100 is 1, isn't it? 20 over 100, well, I could divide the 25 times into 100, so that'll give me 1 over 5, which is just going to leave us with root 5 over 5. So our A is 1 and our B is 5, and that's your final answer. Right, a vector question. So remember, a vector has a size which is both meaning direction and how far you go. So if you've got two different vectors that are parallel, they're going to have a number that you multiply to get, so then however many of it will just be saying how much further that goes. Don't know if that means anything yet, but just stick with it and we'll see how we go. Right, so F to D is A. We've got F to E being B, so I'm going to write that on here. Got that I'm calling little b, and that I'm calling A for the whole way. So we need to prove that PQ is parallel to FE. Well, we know that FE equals B, so we need to get it being a multiple of B, hopefully. Well, we're going to see what we can do. So we've just got to get from P to Q using anything that we could. Now, I could get from P to D by doing half of A, because it said it's the midpoint, couldn't I? So I'm going to say that P to D is half of A, or A over 2. I'm then going to think about how I can get from, and I'm going to say that P to Q is going to be the same thing as D to Q take D to P. So let me change that. I'm thinking, I'm starting at P, so what I'm actually saying is going to be going from P to D and then going from D to Q. So I'm going to be adding those two things together. And you may be thinking, well, that's great, but how do we get from P to D? Well, P to D we've done, that's A over 2, but how do we get from D to Q? Well, first of all, consider that DQ is going to be a half of going from D to E. And we can get from D to E by going down there to F and then across to E. So DE is going to be minus A and then plus B. So that means we can say that DQ is a half of that. So it would be minus A over 2 plus B over 2. Be half of, just instead of going all the way down there and across there, if we just go half down and then across, that gets us from D to Q. Now, what were we trying to go from? We're going from P to Q. So P to Q is P to D, which is A over 2, and we're adding to that D to Q, which is minus A over 2 and plus B over 2. Now, that's going to get rid of our A's and just leave us with B over 2. And we're basically there. So we're proving that they're parallel because PQ is parallel because B over 2 times 2 equals B, which is F to E. And that's all it is. Practice vectors, they always come up. And once you've got the hang of them, they're not that bad. And they're a real key to A-level 2. Okay, here's question 22, which is definitely tricky, but you can pick up 1 or 2 marks just for talking about the area of a circle and for making an equation. Right, so let's go. So area B is going to be, it's pi r squared, isn't it? And the radius is going to be half of that. So 2 minus 2x over 2. That's the same as saying 2 over 2 minus 2x over 2, isn't it? So that's the same as saying 1 minus x is the radius. So B is going to be, the area of B is going to be pi times 1 minus x squared. Just leave that like that for now. That's going to be equal to this area. This area is going to be, A is going to be the big sector, take the small sector. And they're going to be quite related. 45 over out of 360. We want that fraction. Now 45 goes twice into 90, so it's going to go 8 times into 360. So we want 1/8 of a circle. So the big sector is going to be 1/8 of, and it's going to be pi r squared again. So it'll be, the radius will be 2x plus 3x minus 1 is 5x take 1 squared, but we also need to times that by pi, don't we? And then we're going to be taking away 1/8, and the small one is just going to be the 3x take 1 squared. Now that might all look a bit scary, but let's start off by just saying we've got, and that's going to be times by pi 2. I'm going to say I've got this is equal to that. So A is equal to B is going to give me 1/8 of 5x take 1 squared pi take 1/8 of 3x take 1 squared pi is equal to pi times 1 minus x squared. Now you may have noticed everything is being multiplied by pi, so I can get rid of the pi's. I can divide everything by pi and ignore that. Next up, because I've got an 1/8 of both of those, I could kind of take a factor of that out and say that whatever I'm going to get here, let's go one stage more. Let's expand all of our brackets. That's going to get you another mark. We've got 1 so far. So expanding the brackets is going to give us x squared minus 2x plus 1. If you're not sure about doing that, 1 minus x, 1 minus x, gives us x squared, gives us 1, gives us minus x, gives us minus x, adding those together. We're going to get a similar effect on here. When I do 5x minus 1 times itself, that's going to end up giving me 25x squared. It's going to give me minus 5x and then minus 5x again, giving me minus 10x. Do it in a little grid if you like to make it easier, and then plus 1. And then that is going to be taken away from, we're going to have the 9x squared, then we're going to get 2 lots of 3x's minus 6x plus 1 there. That's times by an 8 as well. Now, as we've got everything being multiplied by an 8th here, or divided by 8, we could multiply both sides of our equation by 8. That would get rid of that bracket there and just give me 25x squared, take 10x plus 1, and then I'm going to be taking away 9x squared take 6. Now that's going to have a slightly weird effect. That's going to be taking away 9x squared, but when I take negative 6x, that's going to add 6x, and it's going to take the 1 there. And then all of this times by 8, so 8x squared take 16x plus 8. Now what I've got is a very big quadratic equation. I just need to make the whole thing equal to 0, so gather everything over to one side. But before I do, let's just simplify this bit first of all. 25 take 9 is 16x squared. Minus 10 plus 6 is negative 4x. 1 take 1 is nothing. So I've got 16x squared take 4x. Over here, I've still just got 8x squared take 16x plus 8. Now, I am going to make the whole thing equal to 0. How am I going to do that? I'm going to take 8x squared, I'm going to add 16x, and I'm going to take 8. Just reverse those three things. 16 take 8 is 8x squared. Negative 4 plus 16 is plus 12x. And 0 take 8 is negative 8. So I've got that quadratic, which is quite tricky at the moment, but I notice that all of these have got a factor of 4. I can divide everything by 4, because 0 divided by 4 is 0. 8 divided by 4 is 2x squared plus 3x take 2. And now it's up to you how you factorise that. You can do it using the quadratic formula, or you can do it by factorising by another method if you spot that. And I would do it by that. I would say 2 times negative 2 is negative 4. So I'm looking for a pair of numbers that multiplies to make negative 4 but adds to make 3. And that is 4 times negative 1, because 4 take 1 is 3. So I'm then going to rewrite 2x squared plus 3x take 2 as 2x squared plus 4x take x take 2 equals 0, because that's still 3x there. And I'm going to factorise separately those two bits there. So 2x goes into both of those, x plus 2, and this is going to be one of my brackets, so I'm going to get x plus 2 over here. What do I times these by to get to that? Is minus 1. So it leaves me with 2x take 1, x plus 2 equals 0. So now my two possible answers are x equals negative 2 for that, or 2x equals negative 1, which I could, 2x negative 1 equals 0. If I rearrange that, I get 2x equals 1, x equals a half. Now there's only one solution, because they want the value of x. You can't have a negative dimension. The dimension must be a positive amount. So for that reason, we can just cross that out and say that this is our final answer. Okay, now there's only 3 marks for this question. It's the last question on the paper, and it does make your brain ache a little bit, but it's basically a probability question. So what's the probability of getting a black shape? So black is going to be 3 out of 8 altogether, because there's 3 black and 5 to every 5 white. And what's the probability of getting a triangle? The triangle is going to be 7 out of 9, because there are 2 circles for every 7 triangles. Now I'm just going to draw a little, just start thinking about this in terms of probability, because they want a fraction. You can't work out how many triangles there are for certain, or how many black shapes there are for certain, or how many cards there are for certain. That doesn't actually matter. What matters is the probability. So we're starting off with it could either be black or white. I know it's 3/8 black, I know it's 5/8 for white, because they all add up to 1. Then, if it's black, it could be a triangle, and it could be a circle. I don't know. But what I do know is that it's 7/9 chance of being a triangle, and it's got a 2/9 chance of being black. Now, let's go again. We've got, because we don't know, do we? We just do not know about it, so we're just going to go with it. Oh, hang on. So triangle 7/9 and 2/9 for that. Now, what do we want to know? We want to know how many black shapes there are in comparison to the amount of circles. So black triangles will be 3/8 times 7/9, which is 21/8/9 to 72. And we also need to know how many blacks there are altogether. So we've got 3/8 times 2/9. That is 6/72. So that means black is 21 out of 72 plus 6 out of 72 is 27 out of the 72 that are there. What about triangles though? Because I know I've got 21 triangles, but how many white triangles are there in comparison? Well, you've got 5/8 times 7/9, giving us 35/72. So triangles are going to be this one and this one. So that's 21/72 add 35/72, which is 56 out of 72. And the question was asking us to express the number of cards with a black shape as a fraction of the total number of cards with a triangle. So the number of cards with a black shape are 27 out of the 72, and out of the 72 we would have 56 triangles. So I'm going with 27/56 as the final answer. I hope that made some sense, folks. Just keep on practicing, it will get easier, and see you on paper 2 next time.